Let me introduce our next speaker, Dr. Varun Sharma. Sir is a Doctor of Science in Mechanical Engineering from the University of Kragujevac, Serbia, with over 11 years of academic research and industrial experience across Europe and India. He specializes in advanced materials, porous and metallic foam structures, finite element analysis, and computational modeling. As a former Marie Sklodowska-Curie and EY Horizon 2020 researcher, Dr. Sharma has gained international exposure working in Serbia, Belgium, Austria, Germany, and Netherlands. Sir has authored several research papers in reputed journals and conferences and has delivered expert lectures and training at prestigious institutions such as IITs and NITs. He is actively involved in CAE, simulation-driven engineering, and fostering industry-academia collaborations. We are really privileged to get such an eminent personality as our resource person. Sir has already joined, and I would request, sir, please unmute yourself, sir.
Okay. First of all, I would like to thank you all the uh, members of Elitte College of Engineering for inviting us on this FDP session. I know it's a very big program and it's not easy to conduct, coordinate with all the members in a very short span of time. So I would like to thank Mr. Animesh ji for this, invitation, and Dr. Rajesh ji and all the delegates and members of Elite College of Engineering. I try to create this session specifically for finite element analysis because currently I'm associated with Dassault System EDS Technology, and I'm taking care of CE activities within academia sectors and industrial sectors. And simultaneously, I'm also supporting some of the premium institutes who are conducting R&D on day-to-day basis. So the session is quite interactive. I mean, feel free to raise your hand. I will try to answer it. Okay, and I will also showcase you some of the practical examples during the session. So the agenda which I have created, it is a very unified and very centric agenda. So we'll talk a little bit about the composites. Maybe I will not explain in depth like Professor Debashish explained, but little bit, the fundamentals of composites, and then we'll progress it to finite element modeling, and then we'll talk about some of the examples. And finally, in the last slides, we'll talk about the products because I know there will be a lot of questions about the competency. And finally, you can take some of the, the positive aspects from the slides. So, first of all, as most of the members already know the composites material, let me try to explain in a very simple, short way. So, composite is basically essential kind of a material nowadays, and it is a combination of two or more distinct materials that work together to provide properties that are a single material cannot achieve on its own, right? So if I talk about the basic level, every composites have basically two components. One is the matrix and another one is the reinforcement, right? And matrix is the primary continuous phase which holds together the molecules, I can say, and it also transfer the loads between the components. So it also protect your structures from environmental damages. And if we talk about the reinforcement, which is also which is the another main components and which is embedded inside the matrix. And if you ask me what is the main purpose of reinforcement, so I can tell you it provides the strength and stiffness, and how you design your reinforcement and how you can tailor your mechanical behaviors, it depends on the reinforcements. So if you see my slides, uh, I have explain it in a very like deliberately forms. So we have the first one is your discrete macroscopic particles, So by name, it is reflecting discrete. So it means large particles are dispersed in the matrix. It's a very straightforward. And if you wanted to improve, for example, wear resistance, stiffness, or thermal stability without complex manufacturing, then most of the time they prefer discrete macroscopic particles. And if you talk about the next one, randomly oriented fibers, where your fibers are distributed in many directions, and this gives more isotropic behavior as compared to the aligned fibers. And these are common in automotive industries because of its material tuning capabilities. So that part can also be used. And the another one, if you move on to the fabrics types or specialized technique, then I can tell you we have this align fibers and woven fabrics. Woven fabrics are something about when you have the interlace fibers in multiple directions, and this improves your damage tolerance, and it can also provide very balanced properties. So if you see the pictures, you will have an idea how these practically these fibers orientations are placed. And finally, we have this braided fibers, as you can see here in the picture. This kind of braided architects creates a very complex fiber path and are often used for highly loaded components, and they provides a very good torsional strength and resistance to crack propagations. So these are four of the basics things. So by changing the form and the orientation of the reinforcement, we as an engineer can create a different kind of composites depending upon the mechanical behaviors. And if you wanted to tailor the properties, obviously you can choose the specific type and you can play with that. And these are most widely used composites varieties in aerospace, automotive, and energy sectors. So moving on to the next slides, which is primarily uh, designed to explain you in depth how you can choose the scale of the composites. So the first slide, the first picture in this slides, it's about the scale. It's about your uh, how you can choose the geometry at a different scale. So we have a tank which is a diameters of 1 meters. Okay, it's a very large composite tank. And if you see, we are not concerned with this individual fiber in this particular diagram, right? So instead, we treat this material as a continuous structure, right? And it looks at a global response like a deformation or stress distributions or maybe failure locations. So this is what we call a macroscopic modeling. Let me choose the scale. Yeah. And now if we zoom it in one level, this is the second one. If I started to zoom it, you can see we have this ply level, right? And the other laminate is represented as a stack layers, and each with a specific orientation and thickness. And the ply thickness shown here is very small compared to the full structures. So at this scale, we can start to capture how different layers are interacting and how the stresses transfer between them. And this scale is often called as a mixed scale or mesoscale modeling. And finally, if we again zoom it, it is not a tribo scale, but it is just a zooming scale. And if we zoom all the way in this particular area, we reach this microscopic level where we can actually see individual fibers which are embedded in the matrix. And at this scales, we can model the fiber diameters and the matrix separately, and this level of detail help us in understanding the local stress concentrations and how the fiber matrix interactions and the damage, even initiation mechanism can also be understood. So the key message from this particular slide I can tell you is that composite analysis is a multi-scale, And if you wanted to understand, the full orientations, you can feel free to, choose the scale. Now, let me explain you elaboratively how you can choose it and which scale can help you. So let's say we have these three techniques. Now it is clear, and micro, macro, and mixed. So if you talk about the micro, as you can see, I try to put it only the concrete words. In micro scale, we have the matrix and the reinforcements, which are modeled as a separately, right, as a deformable materials, and we explicitly represent fiber and matrix symmetry if you talk about the micro scale. Now, just make sure this is a very accurate study if you wanted to conduct crack initiation, debonding, as well as fiber breakage. And it can be computationally expensive considering the nodes, alimentations, and all those things. But this is the best way where you can understand, a kind of full structure in the form of small representative volume elements. So this techniques is usually considered where both the matrix and reinforcement are usually considered as a deformable continuum mechania, or you can also say that. Now, if I move on to the next one, which is your macroscopic modeling approach, where your composite is treated as a single equivalent material, and instead of modeling, each fiber, we assign here affective properties, such as orthotropic stiffness, like Professor Devasis sir explained in the first sessions. And this approach is efficient and widely used in structural simulation, especially when you have a very large components like a pressure vessel, or aircraft panels, or automotive structures, we can say. However, this kind of technique cannot capture your micro damage mechanics. So this is certainly the limitations of this technique. Now, moving on to the mixed modeling approach, which is also called as a mesoscale modeling. And this techniques is usually used when you have a multiple reinforcement layers, and each layer obviously has its own orientation and properties. So you can use this kind of approach, and this approach balances your accuracy, and it can also help you to predict interlaminar stresses. So if you see on my right hand side, I have created some of the 3D models in ABAQUS package. So we have this a unit cell created with a very, very simple approach. And this is a mixed modeling approach where you can define different orientations and reinforce layers. Now, the overall, if you ask me, okay, Varun, that's the approach we understand, but what exactly we predicted? So in a short way, I have created this highlighters. So the overall, the choice of modeling depends on your objective, it depends on your accuracy, it depends on your computational resources. Okay, so if you are talking about, or if you are caring about the structural response globally, then macro modeling is sufficient enough. And if you just care about the layer failures, you can use mixed modeling. And if you are care about the fiber level damage, obviously you can go to the micro modeling. So this is actually some of the uh, if and but we always prefer while performing the simulation in ABAQUS. Now, I wanted to talk little bit about the microscopic modeling, uh, how you can represent reinforcing fibers and matrix. So we have a different load cases. First one is load case one, where we have applied a longitudinal loading. And if you see, we have applied the stresses along the fiber directions sigma 1 1, and all other stresses components are 0. So it means you are computing this elastic properties in longitudinal directions. So E11 is your longitudinal modulus, and 12 and 13 is your Poisson ratios. So in a similar fashion, if you wanted to conduct microscopic modeling, you can change the loading directions. I'm pointing to the second image where we are considering the stresses which are perpendicular to the fiber directions. All the pictures that I'm reflecting here from the starting have been created in Simulia ABAQUS package. It's a commercial tool. So this kind of loading you can switch. We have a very specialized module in ABAQUS where you can play with this loading scenario. And the third case we have here is shear loading. And again, here we are applying shear stress, and we can extract the shear modulus. And G11 is basically your shear modulus, while rest of the things we are considering is 0. So, I'm not considering a very complex example, just have taken it rectangular plates and applied the different loading scenarios. So sometimes what happen, we imagine or having a very longer vision to to make it something bigger. Of course you can do that, but in the back of the mind we also have to stick with the basics, because what happen, considering bigger achievement, projecting bigger achievement, sometimes neglecting us to the basics. So always stick with the basics, which help us to execute the bigger task. So now that was the basics, fundamental. Now I would like to represent some of the practical case studies that we have done it for the customers. So, in ABAQUS, we have a very simple, specialized, sophisticated module. You can simply follow that module step by step, and you will be able to complete your composite modeling. So this is the chronological orders, as you can see from my screen. So from part till job, we have, sorry, from part till load, we have pre-processing module, and job is your solver window, and visualization is your post-processing window. Okay, so first you have to create your geometry in ABAQUS, then you can mesh it, and then you can define the elastic properties or plastic properties, and then you can assemble it, and then define the physics, whether it is a static, dynamic, and interactions, and finally the loading conditions, and you can submit your job and you can visualize the results. So that's the hierarchy. Now, so what we did, we have created the geometry in CATIA. Of course, you can do it in ABAQUS as well, but we prefer to do it in CATIA because CATIA is also from the same, our principal company, Dassault Systems. And CATIA and ABAQUS both are using same kernel. So the background algorithms are quite, easy to integrate with each other. So we created the part here and we imported here in ABAQUS as a step file, and then we build up the layup using CAE and composite modeler. It's a specialized plugin available in the ABAQUS environment. And once we have done the import and export part, then we define the properties, and then we done the meshing part. And this picture is basically reflecting the contour stresses. As you can see, blue, green, yellow. Blue part is reflecting the less amount of stresses, basically less concentration stress values, whereas red is representing the high amount of stresses. So the plus sign is reflecting the tension and minus is reflecting the compression. So that's how this color is differentiating the stress value. So now, if you ask me about the, how I have considered the problems, what exactly this is. So this is just the frame, and this frame is resolved under quasi-static analysis using ABAQUS standard algorithm, and we have define certain boundary condition here. This is the fixed part, and again this is the fixed part, and we are interacting this rigid surface with this composites uh, frame, and we have used these properties: ply thickness 0.2, layup values, and material glass epoxy. So these are the elastic properties for the glass and epoxy. I have taken it from certain research paper. And talking about the elements, what elements definitions we can define. Obviously, we have a list of categories: layered shell, solid, stack and layer continuum shells. So considering the capabilities, you can choose solid and shell. We have also used here 3D deformable continuum elements. So we have a list of libraries, and so after we have done the analysis, these are the contour pictures, and on the top you can see von Mises stresses, and this one is penetrating actually. So that was under quasi-static analysis, and beneath we have done the same analysis using dynamic impact using ABAQUS explicit. So ABAQUS standard and explicit are two different solver. Solver means which actually solve your partial differential equations, which calculates the stiffness matrix, which solves the large partial differential equations based on Lagrangian or Eulerian equations. So standard is more specifically designed for static kind of analysis. And if you are into like highly with high velocity, highly dynamic analysis, for example, car is interacting with a wall or something which is falling under the effect of gravity, those are highly dynamic explicit analysis. So here we are using certain wave propagation mechanisms, and in ABAQUS standard we don't use any mechanism. It's simply F is equal to KU, where F is your force, K is the stiffness matrix, and U is the displacement. So that equation is also being used here, and depending upon your physics, you can choose the solvers. We have both this facility in ABAQUS. Now that was basically is a little bit about your how you can model under static and dynamic conditions. Nowadays we also work more specifically on FRC. You might have heard this terminology very explicitly, and let me tell you, this is not an easy task to conduct. So we'll try to explain you in a very simplified manner if you are doing PhD postdocs or maybe R&D. So how you can simulate that kind of composites. So these slides, we try to capture all the informations here in a very confined way. So let's say you have you need to model FRC. Okay, so how this FRC works and how progressively this kind of simulations fails basically. So for example, let's say your composites is actually going to fail. Unlike like metals, composites don't fail suddenly in one step. They basically fail progressively, step by step. So when they fail progressively, so it means the damage starts small, in a small increments, and then it's grow layer by layer, and eventually it leads to the full failures. So that's how this mechanism works. So this slides is actually telling you how you can simulate those gradual damage process. For example, when you start loading, when the loading process begins, the material is initially very still stiff, right? And as you move on, those small stiff eventually leads to micro cracks, and your fiber inside the matrix starts to break, and the stiffness slowly degrades. So instead of instant failure, the structure loses the stiffness over time, which eventually no longer it can carry load. So to capture this behavior, we have to use a very specialized elements, like shell or continuum elements, with a lot of plane stress assumptions. So that was actually some of the sudden informations how your composites is going to break. Now I at least you have an idea. It slowly progress, and then it's eventually break it. Now we have a very famous algorithms, famous theorem, like a classical plate theory explained by professors. We also have Hashim damage criteria. It actually explain you this theory in four different modes. So mode 1, mode 2, mode 3, and mode 4. So your mode 1 is actually telling you how tension failure starts. So in a simple words, we have mode 1 and mode 2. It's predominantly for fibers, and mode 3 and mode 4 is predominantly for matrix. So first mode is for fiber tension failure, and second mode is for fiber compression, and third mode is for matrix in tension, and fourth one is for matrix in compressions. So in simple terms, if you ask me, Varun, what is fiber tension, then I can tell you, when your fibers are stretched too much and snap. So the fibers which are carrying the load, this is usually very critical. So that's how your fiber tension starts. Okay. And if you ask me fiber compressions, it means fibers don't just crush, they can buckle internally, which are leading to instability. Okay. And if you talk about the matrix cracking or matrix in tensions, it means the matrix which are holding the fiber together. When the cracks start initiating, the load transfer between the fibers, it start getting weakening. Okay, so that's how this particular process is working. And finally, the fourth one, which is your matrix under compressions, where your matrix is collapsing under compressive forces. So overall, it is reducing the support of the fibers. So the key idea, I mean, is overall, which I'm telling now, it's about your damage, how you can damage, how you can predict the damage failure progress. Okay, so just keep in mind, if you are struggling to introduce damage, you can go with the Hashim damage model. Now, I try to put all these equations here for fiber tensions, fiber compressions, matrix tension, matrix compressions. So these are basically telling how the simulations are taking the values, and these are mostly your damage initiation criteria. And we have a very specialized sections where you can feed the value of these criteria, and it can showcase you the uh, fatigue sorry the fractures, basically progressive fractures. Okay, so in a simple terms, if you see, these equations basically telling you the current stress to the material strength, and when these values reaches a critical level, your damage initiates. So these are basically your damage variables. Okay, and how it behaves and how it start and how it grow. So these values are predominantly defined here. Okay, so now we'll not talk about these equations in detail, how it is getting derived. It is just to give an idea how it works. So let me directly jump to this interface section. So we have edit material part. Here you can see you have to go to mechanical. You just have to click here and go to this damage for FRC and just select Hashim damage, and here you can define these values. longitudinal strength, tension, compression, transfer, tension, compression, and then longitudinal shear and compression. So it is the same thing which we discussed here, okay, in FRC. Now, for damage evaluation, we are using these equations. These are all your damage variables, which are corresponding to your failure modes for matrix tension and matrix fiber compression. Okay, so I mean, if you are planning to write your own codes, so you can use these equations. It can help you to derive it uh, specifically for damage initiation material behavior. So the second case, let's say if you wanted to introduce damage evolution, we have this functionality as well. You have to go to this particular part, select linear, and here again you will have four different parts, and you can derive the equations and you can apply the values here. And we have a very specialized keywords DAMA, DMA, GFC, similarly MT, MC, or SHR. So, I mean, don't get confused. It's something very similar to your chemistry names, just to, give you quick idea. So, if you are doing keywords or scripting, you can also use these keywords within ABAQUS environments. But just to tell you, these are very straightforward names. And you can feed the values here. And something, different solvers, how it works. If your target is only the maximum degradations in your composites, so you can choose ABAQUS standards. It is actually removing the elements, okay, but not eventually creating the failure. But if you are using the explicit, where you can assume certain failure level, okay, under the same theory, failure fiber modes, and these are some of the conditions we are using while performing the analysis. Actually, these are keywords: section control, element deletions, yes, no, maximum degradation, dmax. So these are the keywords which we are implementing while creating the finite element models. And similarly, in your status file, which is your output file, we have two instructions, 1 and 0. 1 means some of the elements are active. If it is reflecting 0, it means it is completely removed. So that's how we, distinguish between the standard and the explicit solver. Now, based on, our experience, we can tell you, nowadays it's not that easy to simulate composites behavior. I mean, generic analysis you can do, there is no problems, but nowadays the physics is getting more and more complex, considering the new developments. So experimental things cannot identify the elastic properties. So we need to find certain techniques such as virtual environments or AI or ML integration based softwares which can predict the behavior accurately. So I can tell you we have this tool ABAQUS, which can help you to predict delaminations, material damage, failure, and it is being used extensively across globe over a very large period of times because of its accuracy. And this can not only help you to understand the properties, but also you can implement on a very large scales if you are as a startup company or working in R&D sector. So a lot of things can be revealed using ABAQUS tool. And we have all these facilities within ABAQUS environments: linear fractures, crack growth, delaminations, failure theory. And recently we have incorporated the Wu, the Hill, maximum strain, maximum stress algorithms, virtual crack growth techniques, interlaminars, manufacturing calculations, high speeds, draping, buckling, macro, micro. crash worthiness, thickness, and some of the visualizations technique. So it is not just specifically a one tool, but it does includes a lot of specialized composites capabilities. Okay, so now just wanted to highlight you about some of the portfolio extendeds, because we have a very uh, large industries who are continuously developing the tool day in day out. And so these are some of the tools that you can see, like VCCT, or direct links to CATIA VPI, or composites crush. And we also captures some of the industries. We basically merge some of the small scale industries who have done a lot of work in composite sectors. For example, WCM, it is a plugin developed by a French startup companies. Now it is a part of ABAQUS. So we are always expanding our horizons in composite sectors, not just pre-processing sectors or something, but always looking for something which we can include in composite area. And for examples, I would like to showcase you some of the case studies here. Just a second. Okay. So now if we see here, yeah, this one. So, we have captured a lot of practical case studies here, which is purely for composites. Just a second. भाई प्रेजेंटेशन आ रहा हूँ यार, तुम घर गए यार। Apologize. There was somebody else at my door. So, this is one of the case studies we have conducted under tension. So here you can see the displacements. U2 means displacement in y directions. This is another case study, VCCT, virtual crack growth techniques. Uh, that was another examples of YAK. And we have applied here loads and inertia. So we have incorporated various piles here, as you can see here. Okay, so that's how you can see the specific stress value on individual piles. And this one is the ball penetrating through the wall. We have used here explicit solver because of uh, high velocity. uh, the post processing part uh, can simplify in many ways. So this was the direct pictures we have taken, animation videos. Again, this is a windmill. example. The blades are made from composites material, and we can increase the speed as well. Uh, so we have more than 2000 customers, and we are supporting them day in day out. Again, this is a drone examples. We have used here a damage mechanics. Now I hope you get an idea, like this is not just a solver, it does includes a lot of capabilities. Now something little bit wanted to talk about the suit, similar suit, because this is the package portfolio we have used during the simulation part. So you already might have heard ABAQUS, which is for finite element analysis, but we also have EyeSight, Tosca, and FESafe. EyeSight and Tosca, these are for parametric and non-parametric optimization, and FESafe is purely for fatigue calculations. So if you combine all these four software together, you can
Hello,
Sir, yes.
Varun sir, is there any
Sir,
problem?
can you hear us? Sir, your video has stopped and you are not visible too. Your audio is stopped too. Can you connect with us? Uh, I think sir got
Uh,
disconnected.
Participant, wait, he may join again.
Okay, Talapatra sir, you may call him once.
Hmm.
Okay, there are
Uh,
some requests in the chat box. Yes, sir.
Hello,
Yes, sir.
हाँ
Sir
join हो
is
रहा है ना?
joining.
अच्छा अच्छा. Actually, participant, some net issue is happening, so sir will join. Just 1 minute. Sir will join 1 minute. There is some network issue.
Okay, I think someone, Mr. Kannan CR, he has written, coordinators, please share notes for each and every session. It's useful for final exam.
Definitely,
Okay,
I will
thank you so
share.
much. Yes.
I will share every PPT as well as the video. Okay, no problems. After completion of the program, I will share every PPT for every sessions, as well as the video is available in the YouTube. You can see the YouTube of the FDP of the ATAL. There is no issue regarding the session video or PPT. So every video, every PPT, I will share everyone.
Okay, and many of the participants, they have expressed that it's a very nice session. Thank you so much for your active participation. Um, and I think Mr. Vijay Kumar's sir has written, if possible, share PPTs as PDF so that we can
Definitely.
also share to our students in class. That is a very, I mean, the important suggestion.
And one request to every participants, already you know that the 80% attendance of every session is essential, and 70% marks in assessment test will be conducted at the end of the program, the last day. So there will be a scheduled class test, and you have to log in and apply all the portal regarding the class test. That is the session test. So there is no issue regarding the PPT or video. Everything you will get. My request is to attend all the session and attend the assessment test.
Okay. Is it audible now?
Audible. You may
Okay.
say
I
anything.
really
Yes, sir.
apologize. Actually, there is certain, internet issue here. Uh,
It is visible, sir.
Visible? Okay. 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 Uh, so we'll, move on to the next slide. So I will not talk about much about ABAQUS. ABAQUS is primarily for finite element analysis, but overall period of time we also integrate certain tools which can help you to understand more about composites. So we have eyesight. It is for parametric optimizations where you can perform design of experiments, reliability studies and optimizations and Monte Carlo simulations on your composites. And obviously, it is not just for ABAQUS. If you have other specialized tool as well, for example, NXCAD or Excel or MATLAB, that tool can also be integrated here. So, for example, if you see here, we have created complete list of applications which can linked here. So it is work like a drag and drop. It is not like where you have to create a 3D model. 3D part you can do in ABAQUS, but here it is for like linking the plugin. So just create your file and just bring it here and perform the experiments. So this is a very industry adopted tool. So I would request you to just give a try and you will see the benefits of it. Now the third modules we have is non-parametric optimizations, TOSCA. TOSCA is primarily for volume reductions, sizing, shape where you can play with the local stresses, and last one is bead to increase the stiffness. And some of the things we also have incorporated here, which is for fluid optimizations. And this part is like I would not focus much here, but these four modules, topology, sizing, shape and bead, can be used for your composites. And it is a very straightforward and works on a very direct principle where you need to define the variables, objective function and constraint. Very simple and very like practical application oriented tool. Now the last one is the FE-Safe, which is for fatigue and durability analysis. And this tool initially was developed by Andorica. It's an American company. Now it is a part of Dassault Systems. Some of the agreements we have it, but not for all the products. So FE-Safes can be used to predict high cycle fatigue and low cycle fatigue. So this is a practical examples that you can see. Experimentally, it is getting break from here. And if you ask me about the simulation results, again, it is reflecting here. Let me zoom it here. You can see the red spot. So exactly it is giving you the, you know, the hotspot part. And if I again choose the different scale, high level as well as, sorry, high level loading, again, it is reflecting here. And if I combine both the loading high as well as low, it is reflecting the fatigue here, and exactly the same it is reflecting here. So that's the capability of this tool, and it is very accurate. And here you can identify the hotspot area. We say it hotspot, and obviously this hotspot help you to understand the local stresses, and you can optimize your design, increase the product recall and warranty cost, validate your design, and you can correlate your test and analysis. So a lot of these kind of prototypes you can conduct in ABAQUS, and fatigue analysis and FESAFE. So that's the four tool that we have used it here. And just not think about one industry prospect. You can apply in any of the areas, whether you are from consumer sectors or aerospace, life sciences, automotive, and energy sectors. So we have a list of analysis conducting for our customers every year. So this list that you see on my screen, it's presently for last year 2025. Similar slides we will again create for 2026. So you can see the list of analysis we have done it for our customer. Okay. And these are some of the areas. If you talk about the full package, now I also wanted to showcase you some of the development that I have done it over my career, because I'm into this industry for the last 8-9 years. So I have developed some of the specialized tool specifically for composites. So the first tool, which is basically your for porosity analysis, and second one is for your internal shape generations. I have used here AI ML based algorithm, and the same I have used in Intronics as well. So Poroflex can help you to generate 450 plus porosity shapes, porous shapes, and Intronics can generate more than 1200 shapes. And both the softwares, it's a copyright software on my name, and we are we have released the first version, and very soon second versions will release it. We are working on it, and both the tools are capable to create input file of simulations, and this input file you can use in any commercial available softwares, whether ABAQUS or any other tool. So it can solve the equations, but most of the critical part it will be done by Poroflex as well as Entronics, and it can help you to create customizations shape as well. For example, Intronics can fit in aerospace industries. Currently, it is widely used as well. Whereas porosity and poroflex, it's a very innovative new type of engineering materials, widely used in biomedical as well as orthopedic industries, and very soon, applied thermal engineering as well as acoustic engineerings. It is widely, it is going to be used. And these shapes are not easy, to be honest. You need to have a very strong CAD skill and coding skills, and but eventually we have this tool which can help you to create it in a very short span of time. So overall, if you ask me about what it can does, so you can see, for example, if you are working, because nowadays most of the composite engineers, or drone engineers or R&D engineers who are into composites, they are struggling to design such complex shapes, interlayers, reinforcement, or fibers, or plies, and these kind of shapes with different geometrical orientations or topological deviations can be done using these tools. And so you can see my screens. I have created these small geometrical features. And obviously these shapes can be exported in any of the formats. And we can we can eventually apply the complete properties, thermal, mechanical, electrical, or physical properties here. And those properties is going to store in the INP file. And these files you can use directly in FEA solvers. And it's a very like interactive GUI, where you do not have to struggle a lot. Just you have to apply certain geometrical parameters, and you will be able to see the 3D model. Now I would like to take this opportunity, and I would like to conclude here. Since we are from industry side, I try to create a mixture of applications as well as concept. So overall, if I would say, the tool that we are using, we are on daily basis, it's one of the best tools in the market. And we are here to support all the academia peoples as well as industrial peoples. So we are providing global computational supports to our clients. And we are supporting all the IITs, NITs, DRDO, central universities, for their R&D, specifically for their institutions level specific theme based guidance. And we also specialized, and like a team of peoples, expert, who are into this domain. And based on the area of interest, we can create specialized plugin as well, based on the mutual agreements. And obviously we are like 30 years old company, and our principal company does all systems are in the markets for a very long time. And we have a very long strong collaborations with industry, academia, and research. And we do understand it is one of the nurturing areas, composites materials. And we wanted to give our best shot when you are into this domain. So I would like to have more interactions or questions. If you have any, I would like to try to answer it. So that's it from my side.
Varun sir,
Yes,
your
yes,
Thank you
time
so
is
much, sir.
yes.
Thank you so much, sir. I think there are a lot of questions waiting in the chat box.
Okay.
One by yes, sir.
Shall I make it
Sir,
this
can you
one?
have yes? Can you have the access of the chat box? I guess.
Yeah, yes.
Yes, one by one we can go through it. Like Akash Gupta has written, which tool is it for fatigue analysis?
Which one?
The-
It is
So
starting.
I'm just going from the last two, then
Okay. Shall we go from the
adding
top or from the
upwards.
bottom? Shall we grow from
Yes,
the
from top to bottom or bottom to top, whatever you
Okay.
wish.
So the first one, is there any attendance links? Okay, this one, please share the notes, contact detail, uh, the resource persons. Yes, it is there on the screen. You can have my contact informations. If you can capture the screen, obviously you can do that. Let me show you the screen here.
So I can do it one by one for you.
Okay, that's okay.
Okay, Mr. Akash Gupta has written, which tool is it for fatigue analysis? I'm going from bottom to top.
Okay, so for fatigue analysis, I am using ABAQUS. Sorry, FE Safe. This one.
Okay. So the next question is, which tool can be used for torsion testing? Sir, my pronunciation may be wrong because I'm not from mechanical, so sometimes.
Okay. No issue, no issue. I can understand. Torsional
Yeah,
testing,
which,
right?
yeah.
You can use ABAQUS. ABAQUS, it's good tool for torsional testing.
Okay.
ABAQUS.
So the next, okay, sir. Next is the Mr. Amit Pal Singh. He has asked, what is the difference between TISCA and topology optimization? Or
Okay.
TOSCA, yes. TOSCA. Yes, TOSCA and topology optimization.
What is the difference between Tosca and topology?
Yes, sir.
Okay. So Tosca is your name of the tool. Tosca is basically the name of the tool, and topology is for volume reduction. So if you see this picture, one, two, three, the first one is in solid gray shape, right? And in second, blue picture is where you have less volume. So basically, they have eliminate the volume, and in the third picture, gray pictures, they reduce the volume, but at the same time, they maintain the strength. So topology is primarily used when you wanted to remove the volume, and Tosca is the name of the tool. And in all this Tosca optimization strategies, we are using very basic fundamental, design variable, objective function, and constraint, so that you do not have to apply any additional things. And it is a very straightforward hierarchy we have in the tool. Okay,
Okay,
is it clear?
okay, sir.
I mean,
Mhm.
okay.
Yes, sir. Mm, um, I don't have any more question. I would
Which
request to the audience, you can please raise your hand and you can ask
yeah,
question directly to sir.
there is one question from AD Patil. Which tool is used to analyze impact velocity effect on high entropy material? High entropy material. Okay. So, high velocity impact can be solved using explicit solver. Okay. And high entropy materials means you need to define entropy part. We don't define here in ABAQUS. It is only considering elastic plastic damage, structural properties. If you are more concerned on entropy, you need to write, subroutine part, material model. We have two options. One is Python, another one is subroutine. Python, if you are good with Python coding, you can use that. Otherwise, second option is the Fortran subroutine coding, where you can write this material model for entropy. Uh, it would be little bit, lengthy process. I would request to go with the Python, create script file, and directly you can call in ABAQUS. So impact velocity can be resolved then. It is possible, but you have to invest little bit of time specifically for entropy material. Okay.
There is a question from Komal. Uh,
There is one question
asked,
from Samita, Dr. Samita. How repairs can be considered in software analysis? Repair. Ma'am, can you explain repair? You means geometry repair, or how repair can be considered in software analysis? You mean material repair, or uh, where is this one? For UMAT, which one should you use, Python or Ignite? Any two? I need to answer first answer how repair can be considered in software analysis. So repair means, did she reply back? Did she reply back, or I'm not able to see it? How repair can be considered in software analysis? Is it she's going to? Okay, this one, Samita. Yes. In case there is a damage in
in case there is a damage in Yes, Samita replied, I guess.
Hello,
Sir, are you there?
I think, sir, again, any problem is arise, I think.
I think again disconnected.
Hello.
Sir,
Uh,
are you online? Varun sir, are you online?
Yes. I'm online. Actually, it was unmuted. Hello. Is it audible now?
Audible.
yes,
Okay.
sir.
Okay. So we were talking about where is my screen? Okay. So we can, use this damage criteria. So if we use this one, we can see the damage. Uh, you have to scroll a little bit here. You need to define these four values. Certain papers you have to explore it. Okay, this one. A lot of questions. Just a second.
Few of participants are asking about the graphene or nanofiber or nanomaterials. There is a special session regarding this nanofiber, nanofiller or nanotechnology.
Yeah, there
So
will
I
be.
think
Okay. Let me just. I will try to quickly answer. Will you able any question but not able to unmute? This one is previously. Okay, for UMAT, which one should be used? Python or Fortran? Fortran, obviously Fortran. UMAT is for Fortran. प्रशांत जी आपको यूज करना होगा Fortran. Second, Nirvik Banerjee, any tool to analyze mechanical properties of known any in nanoscale. Any tool to analyze mechanical properties. Uh, Actually, I have to say, not able to answer this one. I need to check nanoscale. This is something I did not work at nanoscale. I'm working on developing the composites using randomly oriented where I'm doing validation of flexural, but I wanted to put in properties of material and software like young modelers. It is there. Komal, you can go to which software I don't know you are using, but in ABAQUS, you can define this properties. It is there. We have the section. Okay, this one, Samita, already have done it. I am in work with PLASH as a reinforcement to composite materials. For you suggest kindly what sort of attention should I pay? PLASH with aluminium as a reinforcement to get to good composite material. Okay. I have this facility in Trunix. You can simply define this PLASH as a reinforcement. I have that capability in the tool. You need to try this tool maybe at once. Will you be able to help us in solving HVA of FRP structures? Of course, we can discuss. Please take my contact informations. We can sit and discuss. Sadanand, I want to generate porous structures. Okay. We Can you drop us an email, Sadanandji? I will definitely share you the link for the software. Okay. PLASH we have discussed already. Will you be able to help us discuss? Request you to answer my question to Komal. I think I have done it. I can understand in this short span of time will not be able to answer, but definitely we are happy to discuss again. You can take my okay. my contact informations. I need Poroflex software I want to generate. Whether Poroflex in open, no, it is not open source software. We have invested years in developing this tool. It's not open source, it's a commercial tool. Okay, I think in case of course I'm not be able to satisfy everyone in this, but we are open for discussion again. I am sharing my contact information again. uh, yeah, this one. It is coming as that. Yeah.
So Mr. Satya Prasad has been repeating the question. I
Oh,
think
please
he
again.
is urgently in need of the answer. He urgently needs the answer, I guess.
Input in simulation tool for new. How can you can give input in simulation tool for new composite material? See, it's a very uh, okay. So if you go to this one, slide number 3, this one, uh, we I have told you this is the basic hierarchy we are following in performing the simulation of composites. So first you have to create part. Okay. Second, you have meshing, and then you have property. In property, you have to go to elastic section here. Which one is this one? Yeah, here we have. There must be certain geometrical. Yeah, this one. So in material section, you have to go to general, where you can define the density, and then you have to go to this mechanical part. Second, here you can choose elastic properties if you are only defining Young modulus and Poisson ratio. If you are wanted to understand the damage, then you have to go to this damage for reinforcement. So it is a very straightforward. Create the geometry, go to material, and define here. So that's how this hierarchy basically works. I'm sure ANSYS do the same thing. And I don't know which tool you are using, but in ABAQUS we are following this process. How can you give input in simulation tool? I hope I answer your question. And also, if you are struggling to find, you can look some videos on YouTube. There are plenty of videos. Reinforcement, good composite material. What you suggest? Peel ash with aluminum as a reinforcement. Uh, if you are asking me about computational model, of course you can design peel ash as a aluminum or as a reinforcement. That is possible. And but if you are asking me and it is not straightforward to design it. That's why I said I do have this capability in Intronix and Poroflex, and that tool can help you. If you do not want it to have, you can use coding uh, or specialized software like Rhino, Ceros. Those software can design PLASH, but certain level of programming is required. and afterwards you can define elastic properties or damage properties. Reinforcement is possible. So for example, I was reflecting this picture, something like that, something like that. So you can also create p lash in this form, and it will act as a aluminium reinforcement. So these are R&D topics. You have to have certain level of brainstorming. Okay. Just fix some appointment. We can sit together and we can discuss. Okay. Any more question?
Borun, I think there is no questions. So I have a
Okay.
questions there. So if there is any
Okay.
particulate composite, so in that case, how you model that?
If we have a particular composites, how we can model
Mm-hmm.
it?
Mm-hmm.
Okay. So you are creating the 3D model in ABAQUS, or you are creating in another software?
Suppose we are mixing some powder with aluminum matrix. So in that case, aluminum composite it will be, but it is the particular composite. So
Okay.
how to model that?
So the reinforcement will be your powder, right?
Yes.
Okay. So in that case, see, we ABAQUS cannot create that model. It is not possible. So ABAQUS can solve those powders and matrix interactions. That is possible. But to create the 3D model, you have to have certain third level or third party software. So I mean, I'm not talking about like this tool is the best. For example, you have this blue one is your matrix, and red one is your reinforcement. So which is your aluminum powder. So you can create the shape of the powder and the matrix in Trunix, and create the file, inp file, and that file you can go to ABAQUS and just apply the properties or loading conditions, and you can simply submit. That's the easiest and quick method. But if you have a very simple geometry, something like that, different piles in rectangular forms, then you can use ABAQUS for creating and for solving. But if you have a complex symmetry like nowadays, interlayer laminations, then you need third party softwares which can help you to design those things. I remember when I was doing PhD, there is a software called Woven Fabrics. Uh, it was able to perform textile related composites. And if you are into aircraft engineering, there was another plugin for that. Because composite is having a different kind of physics, and every scale is reflecting different engineering. So maybe not now, or maybe the other way around, you need to have certain level of either coding or certain level of third party softwares which can help you to design it. So I mean, obviously, one tool cannot suffix your problem, solve your problem. So try to have something extra. I mean, obviously, it's not like marketing the software or to make your life easy, but that's how this composite industry, give you the flexibility. If you want an image, I can help you with this aluminum powder reinforcement engineering.
Okay, because we have to use the unit cell model. We have got the various paper. They are basically designed with the help of the unit cell model, but unit cell
Okay.
model will not give the whole matrix property. It will give the particular region property.
Yes, yes, yes. Okay, okay. Yeah, it's possible.
Some participants are asking related to the nanofiber, nanocomposites. So there is a special session regarding this nanocomposite nano at the session number 12. So you will get every information at that session. Anybody, any questions you may ask now? There is a 4 minute left.
Sir, actually, some participants are asking about the process to give attendance. If you can share the idea like how to give the attendance. Kalapatra sir, am I audible?
I'm madam, what are you saying?
Yes. Yeah, some participants are asking for the attendance. That how to
Oh,
give the
attendance.
attendance. The process, yes.
Process, that means feedback form is given, and based on the feedback form, we have to give the attendance in the ATAL portal. So you must fill up the feedback form.
Okay.
So
3 more minutes left. Yes, sir.
3 minutes left. If anybody any questions, you may ask now.
Actually, we haven't read some of the questions which were asked earlier. I'm not sure whether the participants are still there or not.
One
Yes.
participant raised hand. Please
Yes,
unmute
that
him.
time actually. Yes.
Okay, I actually try to answer, but in case something you feel to discuss, please have my contact informations.
Hello, Dr. Varun sir.
Yes, yes, yes,
Sir, actually, this is Dr. Arun Karthikeyan from CBM University, Gujarat, sir.
yes, 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 yes,
Sir,
sir. Yes.
actually, beautiful presentation uh, in all aspects. Actually, presentation. I think you spent a lot of time to prepare these PPTs. I think so.
Yes, yes, yes.
Yeah, so thank you for your inputs for enforcing us to this. Thank you so much.
Thank you, sir. Thank you very much, sir.
Yes, sir.
Thank
Actually, sir, I'm working on metal matrix composite, sir. So
Okay.
aluminum is the base material, along with the silicon carbide and the zirconium oxide particulates. I used to reinforce the aluminum matrix.
Okay.
So I am actually experimentation wise, I have completed all the analysis. So, but even though I want to improvise, I want to extend the work some more aspects. So I am planning to make a simulation actually.
Mm-hmm.
Is it possible to make the model aluminum matrix and ceramic reinforcements, two different
Yes,
ceramic reinforcement? So
yes,
how
yes.
if you know about anything, I mean, if you have the knowledge on this, please share it with us, sir. It will be helpful for us.
See, it is possible reinforcement, metric reinforcement. That is possible. There are a lot of customers, industrial customers. They are doing it. Maybe you can drop us an email. I can share you the practical case studies.
Okay, okay, sir.
Just drop us. I will share it.
Okay, so is there any possibility to make a collaboration or kind of, I mean, is there any way to collaborate with your industry, sir?
Sir, you are from academia per section
Uh,
or?
yes, sir. I am from academia background only, sir.
Okay, academic backgrounds. Okay, okay. We can do that based on mutually agreed area of interest. But we used to do that. There is no problem in that, obviously. Uh,
Okay. If
yeah.
consultancy wise also no problems, sir. Means so we are ready to. We are dealing with some problems actually, but if it is through simulation, it will be good for us actually. because here also we are trying something, but we are not getting the result up to the mark.
Okay, okay, okay.
So first we are going with the simulation point of view. Then, if you are satisfied, then we will go with the experimentation. It will be easy because the experimentation cost is very high, sir. Actually, so
Okay. Okay.
yeah.
No,
So
no,
definitely,
we
sure,
are
sure.
we are
Yes.
open for that. We are supporting all the IITs, NITs, central universities. So we
Okay.
are doing, collaborations or academia sessions specifically for faculty development programs. We are creating theme-based session also. So there is no, challenge in declining the request. Obviously, we are open for expansion. So just feel free to share, sir. We can discuss later on.
Okay, sir. Sure. Thank you so much, sir. Thanks for the patience. Actually.
Thank you, sir. Thank you. Thank you.
Okay, thank you, sir, for this really enriching and thought-provoking session.
Thank you.
And thank you, audience, for your active participation. So I hereby announce the conclusion of the first day's sessions, and we sincerely thank our esteemed dignitaries, speakers, and participants for their active participation and cooperation. So with this, the organizing team is signing off for the day, and we look forward to welcoming you back tomorrow at 6:30 p.m. sharp. Thank you so much.
Thank you. Thank you, Animeshi. Thank you, ma'am. Thank you, everyone. Thank you.
Thank you, sir. And good night to
Thank
all.
you. Thank you,
Thank you.
Varun sir.
Thank you, sir. Thank you.